Okay, today we will talk about main characteristics and simple applications of operational amplifiers. Uh, the members of our team are Lacio Resendiz Oscar, Lara Rendón Audrey Ernesto, Hernán Vez de Antes Alan de Jesús, Víctor Leonardo Mendoza Aguilar, and Moreno Díaz Omar Maximiliano.
Operational amplifier was called to early high gain vacuum tube amplifiers designed to perform mathematical operation of addition, subtraction, multiplication, division, differentiation, and integration to solve some equations. The successor of those works at lower voltages in low cost and are used to perform in fields of process control, communications, computers, etc. Next, please. The symbol of the arrowhead symbolizes the points of input and output direction of signal flow. Next, please. OpAmps have five basic terminals, two for supply power, two for input signals, and one for output. Next, please. The, the, ide- the ideal OpAmp has infinite gain and infinite frequency response. The input terminals draw no signal or bias currents and exhibit infinite input resistance. Output impedance is 0 ohms and the power supply voltage are without limit. Next, please. OPM terminals positive V voltage and negative voltage must be connected to the power supply, but the power supply has three terminals, positive, negative, and power supply common. Next, please. The power supply common terminal may or may not be wired to earth ground via the third wire of the line cord. All voltage measurements are made with respect to power supply common.
Okay, then we have the output terminal. Since there is only one output terminal in one operational amplifier, and this is called a single-ended output, there is a limit to the current that can be drawn from the output terminal voltage levels. These limits are set by the supply voltages and by the operational amplifier's output transistors. Most of the operational amplifiers, like the 741, have the internal circuitry that automatically limit current drawn from the output terminal. Even with a short circuit for RL, output current is limited about 25 milliamperes. This feature prevents destruction of the operational amplifier in the event of a short circuit. This is an example of that. And then we have only one output terminal and it's a single-ended output. The output terminal. Output voltage, VO, is measured with respect to ground. This operational amplifier output terminal is connected to one side of the load resistor, RL. This is the output connected to this load RL. And then in this case, RL is wired to ground, that is connected to ground. Output, then RL, and finally connected to ground. Input terminals. There are two input terminals called differential input terminals labeled negative and positive. They are called that way because the output voltage V0 depends on the difference in voltage between them and the gain of the amplifier. Now we see in this and this the differential input terminals that one is negative and the other is positive. Both input voltages are measured with respect to ground to sign of ED. Tell us the polarity of the positive input with respect of the negative input, and the polarity of the output terminal respect to the ground. We have this to explain the ED voltage as, as the positive input and the voltage as the negative input. Then input bias current and offset voltage. Now we have some calculation of the input current and the offset voltage depending on the input bias. The input terminals of real operational amplifiers draw tiny bias currents and signal currents to activate the internal transistors. Then the input terminals also have a small imbalance called input offset voltage, VIO. It is modeled as a voltage source, VIO, in series with the positive input.
The open loop voltage gain is defined as the possible feedback between the connection from the output terminal to input terminals are left open. As we can see, the output voltage, or as we are referring in this case, V0, is determined by the differential input voltage, EV, and the open loop voltage gain, AOL. Accordingly, V0 is expressed by the relationship in the formula V0, or the output voltage, is equal as the differential input voltage uh, multiplied by the open loop gain. In the differential input voltage ED, the value of AO is extremely large, often 2,000, not 200,000 or more. V0 can never exceed the positive or negative saturation voltages plus Vsat or minus Vsat. For a plus minus 15 minus supply, the saturation voltage are approximately plus minus 13 volts. Thus, for the operation amp to act as an amplifier, it must be limited to a maximum voltage of plus minus 65 microvolts.
Okay, and in conclusions, B0 either will be at one of the limits, positive voltage SAT or negative voltage SAT, or will be oscillating between these limits. This behavior is what a high gain amplifier usually does. To maintain B0 between these limits, we must go to a feedback type of circuit that forces B0 to depend on stable precision elements such as resistors and capacitors. Without learning any more about the operational amplifier, it is possible to understand basic comparator applications. For example, we can see the V0 and the voltage and the amperes, positive and negative, and the minus and positives. Zero crossing detectors. A non-inverting zero crossing detector. The polarity of voltage or V tells, in a kind of way to say, if E is above or below where the transition of V. Tell us when E crosses the reference and in what direction. For example, when V makes a positive going transmission from negative VGA10 positive VA, it indicates that in just crossed zero in the positive direction. The circuit of the next slide is a non-converting zero crossing detector. That is the example, and some of the lectures that a non-inverting show. Inverting zero crossing detector, if the signal or voltage to be monitored is connected to positive inputs, a non-inverting comparator results. If the signal or voltage to be monitored is connected to the negative inputs, an intervening comparator results. In general, when V is equal to positive V sat, the signal is above, more positive than V ref, is non-inverting comparator, and below, more negative than VREF. VREF in an inverting comparator. We have a positive inverting comparator and the type of signals that it shows.
Positive and negative voltage level detector. Next. In the figure 2.5, a positive reference voltage is applied to one of the op-amp inputs. This means that the op-amps is set up a comparator detector, a positive voltage. If the voltage to the sense E is applied to the OMP plus input in the result non-inverting positive level detector, its operation is shown by the wave shapes when A is above voltage, voltage equals plus voltage sat. When E is below voltage, voltage 0 equals minus voltage. The circuit is an inverting positive detector. The basic configuration for the positive voltage comparator also known as no-inverting comparator circuit detector. When the input signal voltage in is above and more positive than the reference voltage introducing in the output voltage out, which is a high and shown. Next. Uh, Adjustable reference voltage. A digital adjustable voltage refers to useful in many applications. For instance, it can be useful to finely tune to the reference voltage when absolute equality is required. To adjust the reference voltage to the match the full-scale voltage range of the analogic input signal to maximize the dynamic range of the analog to the digital conversion. Next. Using the digital variable aspect of the digital put to control the adjustment voltage on the reference result in a flexible and useful circuit. How can you see in the match? The voltage detector is an operational amplifier are used in circuits which the output is switched between a positive and negative saturation voltage, V plus and minus voltage. The actual voltage change that occurs is known as the output voltage swing
For many op-amps, the output saturation voltages are typically supply voltage levels minus 1 voltage. Zone activate switch. A practical application that uses a positive detector is a zone activate switch shown in the figure 2.2a. Signal source A is a microphone and alarm circuit. You need connect to the output to pursue the arm the zone switch as follow. A variable reference voltage can be obtained by using the open and bipolar supply, along with the voltage driver network. Next, the diode now conducts a current pulse of about 1 milliampere into the gate G and of the silicon controller reference SCR. Normally, the SCR anode I and cathode K terminals act like open switch wherever the gate current pulse make the SCR to run, and note the anode and the cathode terminals act like closed switch.
Well, I'm going to talk about light column voltmeter. A light column voltmeter displays a column of light whose weight is proportional to voltage. Manufacturers of audio and medical equipment may replace analog meter panels with light column voltmeters because they are easier to read at a distance. And you can see an example. It's an image of a light column voltmeter. Next, please. Well, and this is the schematic circuit. Reference voltage to each operational amplifier are in steps of 1 volt as E is increased from 1V to 10V. LED 1 through LED 10 like in sequence. R1 to R10 are 1% resistor. The operational amplifiers are 741 8-pin mini dips, and in the image you can see the LEDs, LED 1, 2, 9 and 10, and the uh, operational amplifiers that are connected to the LED and do the function. Next, please. Well, now the smoke detector. The lamp and photoconductive cell are mounted in an enclosed chamber that admits smoke or dust, but not external light. The photoconductor is a light sensitive resistor. In the absence of smoke or dust, very little light strikes the photoconductor and its resistance stays at some high value, typically several hundred kilo ohms. Next, please. And this is the example, well, an image of the sensor, a smoke sensor. And the smoke particles are the smoke or gas, and you can see the lamp and the photoconductor CL5M9M. And the next it's the 741 operational amplifier, and at the end this is a sonar, and this is the uh, schematical circuit. Next, please. Well, any particles entering the chamber cause light to reflect of the particles and strike the photoconductor. This is the these are many examples of how function the circuit. Number two, this is turn causes the photoconductor's resistance decrease and the voltage across R. Number three, when the particles leave the chamber, the photoconductor resistor increases and the alarm turn off. Number four, if we want to alarm to stay on, could be use an SSR. And well, the photoelectric alarm work using a photoelectric sensor and a light source as smoke enters the chamber and crosses the path of the light beam. Light is scattered by the smoke particles, aiming it toward the sensor, which in turn triggers the alarm.
And now this is all for us and for our team of the main characteristics and simple applications of operational amplifier. Thank you.